This is January '07 question 5 from module 4. Again, this is a gravitational question. Communication satellites usually placed in geostationary orbit. The radius of such an orbit has a definite value. State two other features of a geostationary orbit. Well, the two features then that we would need to identify there are that it's an equatorial orbit, so the satellite orbits above the equator. Okay, so it's going around equatorial, it's going around the middle of the Earth rather than across around the poles. So it orbits above the equator. And the second thing then is that the period of orbit must be 24 hours, so that it takes the same time to orbit as the Earth itself does, and that maintains it in a fixed position relative to the surface of the Earth. Alright, so the mass of the Earth is 6 times 10 to the 24 kilograms. Calculate the radius of a geostationary orbit. So what we're going to do then, again, and this is something that we're very familiar with, GMM over r squared equal to mr omega squared. The m's cancel out, and so we then have, we're looking for r, so we get gm over omega squared equal to r cubed, and we're also going to use the fact that t equals 2 pi over omega, so that means therefore that we've got r cubed equal to gm, and then we're going to put in 2 pi over t, so that becomes 4 pi squared t squared. So we're going to simply fill in the values here. So we had g is 6.67 times 10 to the minus 11 from our formula sheet, times the mass of the Earth, we were just told, 6 times 10 to the 24, times and t squared. Well, that's 24 hours, so that's 24 times 3,600 seconds, and we have to square that, and just make sure you square that, divided by 4 times pi squared. So fill that in, r cubed, then r then is equal to the cube root of that value that we had, and 6.67 times 10 to the minus 11 times 6 times 10 to the 24 times 24 times 3600 all squared divided by 4 pi squared. And that gives a value for the radius equal to 4.23 times 10 to the power of 7. So 4.23 times 10 to the 7 meters is the radius of that orbit. A daily influx of meteorites and meteor dust is well known to scientists, but the total mass added daily to their surface is difficult to estimate. Some scientists estimate that 7.9 times 10 to 7 kilograms is added per year. Calculate how many years it would take for the gravitational field strength at the surface of the Earth to increase by 0.1%. Assume that the increase in mass continues at a steady rate and that the radius of the Earth is unaltered. Okay, so the radius of the Earth, we've got a value for the gravitational field strength at the Earth's surface is equal to that. So